Hello, Shinobi. Eh, I don't know. I don't usually love Electro Swing. This is the one YouTube video that I find okay. Most of them are, I don't know. To me, they sound like slop. But this one I like. Hello, Zig. Okay, so what are we doing today? Ba-ba-ba-ba-bum. Will it be the next Open Source Saturday? No, I don't think I will. I don't even know when it is actually, but there is a Zig Day on December 6th. So December 6th. I will be here. Actually, did I have SVP? I think I did, yeah. Yeah, 19 attendees. Okay. Yeah, it's hard to keep up with all the social stuff now that I do Zig Days regularly. So I'll come back to Open Source Saturday for sure. It just depends on the period. Also, I'm going at the end of this week to Nuremberg. I'll be here, so that's why I'm not really coming to Open Source Saturday much lately. It's just that I'm doing all these other things. What about FOSDEM? Oh, no, FOSDEM. Never been to FOSDEM. I don't think I'll easily go. There is no Zig room organized for FOSDEM as far as I know. And I participated to one FOSDEM, which is the one that happened during the pandemic, the online one. I did organize a Zig dev room when that happened. I had a horrendous experience being a room organizer. I absolutely dislike everything about how FOSDEM deals with that kind of organization and like organizing that stuff. So I after that experience, I said I remember saying to people in the Zig community that if anybody wants to have a Zig dev room at FOSDEM, they will have to be the ones that do the work of organizing it. I'm not gonna do it. I would be happy to support in any capacity that is not dealing with the FOSDEM people, and but so far nobody has ever stepped up. Nobody has really cared about organizing a dev room. So sorry, no FOSDEM for me. And this is not to say that FOSDEM that I think that FOSDEM is a particularly bad event. It's just that that there, if there is no Zig specific thing, it's harder for me to be there because same reason as Open Source Saturday. It's like I have a limited capacity for socialization, and I prefer. Well, I have to basically use my limited resources to do stuff that makes sense with regards to Zig. What was horrendous about the FOSDEM stuff? Well, they have these weird mailing lists where they put like 100 people in there, and you keep getting spammed by everybody about every weird thing. And they have multiple of those. You get subscribed to all of them, and it's just an endless amount of spam that it just never ends. And then in the middle of these like tiny discussions that you don't care about because they are specific to like one guy. Then they also put announcements in there that you do care about. So it's not like you can just mute them. Or you know what? I don't know. Maybe nowadays you can, but at the time when I did it, I couldn't just mute those threads because there would be occasionally information that was important for me. It was just in an ocean of garbage. And yeah, I think that there is something inherently wrong with organizations that are like too affiliated to free software, like the free software movement. I don't know what's wrong with them, but they just like bad stuff, in my opinion, and I can't. I don't want to deal with that. So I don't know. I find that it is it's a thing that I've seen being done by multiple things that are like free software affiliated or like free software adjacent. And at this point, I started, it's like you eat something made out of goat, and you can tell that it's goat because everything tastes like goat, like it smells like goat, right? So you try 2-3 times, and after a while you do realize that, man, everything that is made out of goat has like smells like goat a lot. So to me, I feel like I can smell free software sometimes. That's the free software movement. That's my perspective. Anyway, so we have some work to do here. We have to take a look at IoT cancellation, but there are other people that do go there, like also Zig people. So you might find somebody. Some people enjoy that space. Okay, what's the plan for today? I still need to announce the stream. So let's actually do the IO thread cancellation stuff for real at this point, at least some of it. So looking into IO, into async cancellation stuff, trying out Andrew's patch, then Z work. Or maybe not in this order. Maybe we should do the opposite. Actually, Ziggy work first, then async. There we go. Do-do-do. Okay. So, let's put it. Leave it there. Then we can continue the async. The YAML stuff. Delicious YAML. We did look into YAML, although it wasn't entirely clear to me how to navigate from parent to child. So that is maybe something that we'll need to figure out. We also have the problem that we need to learn more about this. We also need to learn more about hey, Neuroside. Okay, so we need to copy more of this structure. 1,000 lines, 100,000 lines of Zig written, and today you learned what saturating subtraction does. There's also the assignment version, so it's minus pipe equal sign. So it's you know how was it? Rust has the thing that they call it like the turbo fish. Is it like this? I don't even know what the fuck is a turbo fish even. I don't know. is it a spaceship? I don't know. They have some. I don't think this is valid Rust. I might be wrong, but in any case, they have something like that. We have I don't know what is this. Maybe we should call it the loss operator for people in chat who know what I'm referring to. In any case, I'm gonna fill up my cup with tea, and then which is already made, so it's gonna be quick, and then we can start stuff. I see. By the way, so Neurosite, here's a question for you. Are you gonna switch to the lib async stuff? Take your time to answer that. I'll go get my tea. Okay, I'm back. But we had a good run. The people watching this stream without music, they have no idea what I'm talking about. Hey, so delicious. Hello. By the way, there is one thing that I think should be said about you two guys. So, setting aside the fact that you both have a 0 in your nickname, like I don't know if Neurosite wants in Flow the feature that your extension, that your patch basically for now provides to Helix, so delicious, but I don't know. I feel like you two should talk a little bit at least. So You guys should have a chat. You know, so that you stop gifting tech to Helix and you start hoarding it into Flow. Oh, you did already. Okay. Wait, when? When did you chat? Because you've never been both at the same event, right? I mean, I know that I heard about this thing called computer where you can chat with people at a distance. But I see. um yeah. Okay, I'll tell you my plan. My plan is to get cancellation right in async.io in Zig, and then I'm gonna start. I will resume D2. I think it's time to resume D2. Yeah, yeah, that's him, the one and only. And oh, by the way, Solicious, are you coming to Nuremberg? Or are you one of those Southern German guys that like hates Nuremberg because it's just a little bit too north of Bayern? Yeah, I know. You know what? I did a build earlier today. I have latest flow in here. I know I'm getting so much fucking close to doing it. I'm just being a you know what? I'm just being a pussy right now. I should try. What? Wait. Oh, it's not case insensitive. Okay. You know, tiny things that take you by surprise. I expect a message and see the in close for okay. Well, you know what you might want to have? A language server restart thing because that's needed. Restarting LSPs is kind of important, especially when you're making a janky one. Just restart flow. Yeah, I know that I could restart flow, but sometimes it's convenient to be able to just restart the language server without having to wait. Oh, that takes you back here. Is that the thing? I see. Oh, okay. Yo, what are these dots? Are those like gate differences? Yeah, those are gate differences. Wait, there's yo fancy stuff. You know what, man? It is tempting. I could try to do this now. Uh, but there is no go to definition, is there? Your side. I know that I'm being a whiny non-user. And why is it not freaking working? What's wrong with I'm getting oh wait. That might be on me. Yeah. I switched back to 015 I switched back to 015.2 to build flow. And now I need to go back to okay. What am I doing? Still not working though. Mm-mm. Go to references. Command not found. Go to reference. Those two are kind of important for my use case personally. Wait a second. Wait a second. You're allowing. Wait a second. Wait a second. You're allowing the cursor to go off screen and stay where it is. So I can go up here and then I can do append and I'm back here. Oh my god, this is a fucking orgasm. I hate so much the fact that the cursor cannot go off screen in other editors. It used to drive me nuts. Then I got used to it, but I still viscerally hate that limitation, like that weirdo behavior. And oh my god. No, that's not my LSP. That's or rather, it's not one of mine that are broken. That's ZLS. I don't know. I was doing go to definition on this guy. I don't know why it's not working in Flow. Wait a second. How are you even scrolling? What is going on? What is going on? What is going on? Okay. Jesus. Your side. I'm kind of sold. Please go to definition. I don't know. It just says unexpected message std in close. So there's something going out of whack with the LSP. Well, the fact that movement is not like just snappy, but there's like this concept of scrolling around, which I like. Sorry, maybe you guys don't see this on Twitch. I don't know if it's too fast. No, you do see it. But in any case, I like that it's not just, snapping from one thing to the other. I think it's nice. So this is all cool, but yeah, I need go to definition working, man. I don't know why it's pooping itself. Says unexpected message. It means the LSP exited unexpectedly. Yeah. Well, let's see. Why are you crashing, ZLS? There's no ZLS. Invite target URI. I think it already complained. Check the LSP log. The LSP log is not saying much. The LSP log itself is really not saying much. If you mean the LSP log is in the one that ZLS makes, there's not much there. The URI is file:/. Oh yeah, That needs to be file colon // and then /foobar. Flows LSP log. How do I see this stuff? Log. Oh, view log. Okay. Yep. Bro, that's not a thing. That's not a thing, my friend. It's a bug in ZLS? I don't think so. No, you generate these guys. These URI is it's decided by the client. That's not flow. Oh, you're right. You're right. This is not a message that comes from you. This is a message that comes from ZLS. That is fair, but I believe that it's you who generates this URI. Check the flow LSP log. LSP. I don't know. I saw view log. What else should I be looking at? You expand this guy? You can expand this guy. Local state flow LSP Zig log. Okay. Exists expression from these are diagnostics. Okay, so far so good, maybe. But URI file colon / this is so weird. This is weird. This should not be like this. It's a ZLS bug. Oh my god. Oh my fucking god. Go to definition. Error. Invalid target URI. SCT.zig. Yeah. How is this happening, man? No. No. What is happening? Oh no, we need Decatrix. I'm gonna ping him. I ping Decatrix. We'll see. But it's so weird because well, you know, they have some advanced handling stuff based on fucking Windows and who knows what's happening in there. Oh, Decatrix says, I'll join the stream. Awesome. Yeah, well, you already did the flow send for request. That is a good question. I don't know how to parse this stuff visually yet. Requests still have the same structure, right? How do I recognize them as, oh, send request. There we go. No, you did right. Oh God, you you definitely did right. That's not on you. Yeah. Go to definition, this file, blah, blah, blah. Yeah, I wonder how do other editors make this shit work? Because I can do go to definition on this guy and it works. What the heck? What a mess. No, go to last access file. No, that one is also kind of critical to have. Oh, I guess I can do, at least I can do this. The Helix have log. I think so, yes. The way it works is that you start Helix with a bunch of verbose flags. Then you tail Helix log, I think. And then there's going to be a bunch of crap in here. Okay, so then we do this. Then we go here, we go scoped, go to definition, and document color. There you go. Publish diagnostics, URI, string file. Yeah, this is busted. Hey, Techatrix. So here's the long story short of what we're observing. We're observing ZLS producing these document URIs, and they look sus. They're missing a couple of slashes after the file colon prefix. And for some reason, like, they should look like this. But ZLS speaks this, which is turbo weird. That said, it seems that Helix supports this. Are you on latest master? That is a fair point. I'm on. Okay, you know what? I might have. I might have annoyed you for no reason. Git pull. Haven't updated in. Well, I was somewhat on a somewhat recent commit, but not super new commit. So, I'm seeing the same thing on master. Okay. Zig build release fast. Yeah, but as you can see, I don't have a ton of changes. So I unless these two files are the ones that contain the fix, but otherwise no. So yeah, no, these things are weirdo. It's also super weird though that Helix doesn't complain. That surprises me. Man, I'm so tempted to switch to Flow. I think my time to start switching to Flow is coming. Might not be today, but holy shit, we are so close. But now I want to see how my stuff works. Oh, I was saying, wait, why is my stuff not working? Why is my go to definition not LSP stuff not working in Flow? And then I remembered, wait, it's a different editor. It's not configured. Maybe. Or all right. I don't know for sure, but probably not configured. So Yeah, also I think this grammar is old. Yeah, look, the three-seater grammar is also old. It doesn't recognize this stuff. On stream if you want. Holy shit. This is so fucking tempting, Neurosite. Like, no joke. Okay, I would say this. Once ZLS fixes this, and I have it on my computer without this issue anymore, then we can take a look. Ooh. Okay. In any case, cool shit. Very, very cool shit. Very cool shit. I'm excited. With all due respect to Helix, good editor, but I'm excited. Oh yeah, M mode is also nice to have. Also, you know what we need to do? Here's one last thing that we need to do. Here's one gigantic pet peeve that I have right now with Helix. Although this has nothing to do with Helix specifically. This is a mistake in the Zig grammar that Helix uses. I would like to do match. So look at this nice menu. Match around. And then I would like to do this on a argument slash parameter. I would like to match around this because sometimes I'm editing like parameters in a function definition or arguments in a function call, and this fucking grammar doesn't make that work. We should get all this stuff right for Zig. God damn it. Okay, so what we're looking at, const iterator. Your fork is like years behind. Really? You know what? I'm not even sure I'm using your fork right now, though. You know. Because I have some of the new features. So as you can see, I'm not using your extension right now because I disabled it at some point and then I didn't turn it back on. Or I think it something about it like bit rot a little bit. Like it started giving me false like wrong information up here. So that's probably one of the reasons why I didn't bother re-enabling it. Hmm. Yeah, I remember. I remember when I announced that, but I think I have this. I have 2501. Is that new at all? Yeah, of course it's in .cargo. Fill your fork. Oh fuck! So I'm not using. Okay, I should probably then. Let's see. Text objects. SCM needs merge. Oh, guess what? Git stash. Error could not write index. Unable to do what? Sorry? Of course, a bajillion files have changed. I saw a bunch of unable to do something errors, and then wait, I have a scroll bar. We now have a scroll bar in Ghosty. So I saw a bunch of unable to do stuff. Where's this stuff? Unable to RM there. What is it? Cargo install external locked. Okay, let's see how this goes. Okay, what are we doing? Somebody was asking, what are you working on this time? I'm rebuilding my text editor written in Rust. So this is going to take probably 1/3 of the stream. After this is done, hey Andrew, after my editor is rebuilt, then by the way, okay, so Andrew, since you're here, yeah, Electro's winging. No, what are these errors? Guys, you told me that stuff with Rust just builds without having to think about it. What the fuck is going on here? What is going on? File to run custom command for this error. libc. Am I running out of disk space? I think there's this guy that can tell you if you have no. Well, I think before we can get into this, we can just do utility. I have 53 gigabytes, so no, that's not it. What's happening? Signal 9, sig kill. Terminated by signal sig kill force quit. What does that even mean? Malformed macro file? What? Take your time with the stream, but I was going to ask if you wanted to move this SF team meeting earlier today. Oof. At what time? I'm personally super fine with that. Kinda, as in, I don't know. Couple hours from now? Fuck yes. Okay, I was worried you would just want to like pull it back a couple hours. That would have been problematic for me, but a couple hours from now, totally, yeah, for sure. Definitely. Let's do it. So that would be 5:30 p.m. kind of for me. That sounds good. Maybe try cargo clean. Yeah, cargo clean. Okay. Let's try again. Nope. Fail to run custom build command for parking lot core. I'm not ooming. You mean the entire system is not ooming? I don't think so. I have 32 gigs of RAM. I'm using 9. That's not Update the Rust compiler. Right. Wait a second. Shouldn't it be like telling me if I have an old version of... What is this? Is this Zig? I thought I was using Rust. Reinstall Rust... wait, Rust up? Rust up? Show update. Rust up update. Error. Component Rust SSD for target version 32 was is unavailable for download or channel stable. You need the component. You could try a manual installation with... No, if you require these components, please install and use the build version. Then you can use the tool chain. You know what? I don't care about wasm32 WASI. Can I remove it? Can you uninstall stuff? Rust up update stable. Rust up wasm32 WASI remove. Unexpected argument remove found. Uninstall. But wait, this thing was saying rust up component. Oh, wait. Okay, I understood now. It's lowercase. So it's rust up component remove wasm32 WASI. Error. Toolchain, blah, 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 does not contain one error for target. Okay, I'll read more. One of many components listed above might have been permanently removed. Okay. So we're good. I think this is kind of this error is kind of like failed successfully. Never mind. We're still failing. Period. Help, chat. How do you solve these in Rust? What am I rusting wrong? Okay, you know what I think might help. No, I don't think it will. But since while we're here, actually, let me do this. Which Rust? What the fuck does... Wait, what does nothing mean? Oh, there's no Rust. Is it Rust C? Okay. It's in cargo. Which Rust up? It's still in cargo. Which cargo? Well, okay. Dash toolchain. Wait, where do I put that? Should I pull brew into the mix at this point? Is there a new command? Maybe it's not cargo install path anymore. It's something different now, maybe. But also, fucking macros, man. I told you that they were S, and they still are. They still prove that they're S. Let's take a look at the Helix website. Maybe I'm missing something. Installation, building from source. I could just do brew install Helix, to be fair, but... Yeah, no. Oh, wait, what? If you're using the muscle libc standard library instead of glibc, the following are... No, that doesn't pertain us. Reproducible, optimized. Fuck it, optimized. Somehow I suspect that this is not going to help us much, but yeah, parking lot core really hates macOS. What Rust version do you use? Good question. Cargo version. Cargo 182 Rust C version. 182. Wait, didn't I try to upgrade this thing? Why does it need to run a custom build command? Oh, Andrew, I can tell you why. Because if you don't pass, this part, I think it's because this project has a bunch of different like flavors of Helix. So I think this is kind of telling it's kind. Okay, I think that this is specifying a specific build script to run. So we're telling Cargo to run the build script from inside this directory. And the reason why we're doing this is because Helix has a few different targets that I guess it handles that way. The -- locked is because if you don't do that, you get the mystery mix versioning. So you get that the compiler, the package manager tries to fetch the newest, most compromised version of a package and tries to use that one. So we use locked to get same behavior. As for this, I don't know. This is probably like something like, well, this is like our release fast, I'm guessing. Yeah, no, Rest Stop update did not work. Like, I'm getting these errors and it's not telling me what the fuck to do about this. Component Rust STD for target wasn't 32 WASI is unavailable to download for channel stable. At some point I remember doing something to get the ability to target WASI from Rust. And I guess this has now become, one of those scenes that go from generation to generation. Like my children will also be unable to do certain things because I installed wasn't 32 WASI. So, but it doesn't tell me how to get rid of this fucking thing. Component for target. So can I do Rust Stop component remove? The component is Rust STD in this case. So Rust STD -- tool chain. Oh, no. Wait. Maybe it's the target they want to remove. Target remove tool chain stable wasm 32 WASI. Let's go. Okay. We're making progress. I'm learning Rust. Okay. We have too fucking easy, man. Now let me go fish in my history. The optimize command? No, never mind. This thing is still cargo clean. Gotta clean my cargo pants because the package manager took a shit in them. And no, never mind. Parking lot core. Parking lot core is just hating me. If you updated Rust, then how come it ran install? It had cache artifacts still. It is a great question. What is the answer? I don't know. Stable ABI? I don't know. What if you specify the target? But I mean, it's like just my fucking computer. Also, this used to work. Like, at least this one used to work. It's just this fucking parking lot core that fails on macOS. Also, I have to say this thing. Cargo clean does not seem to be doing much. Cargo clean, like all this stuff, it's not really doing much, really. Because, there's really not a lot of difference. Except all these things failing. Fail to run custom build command for libc. Try manually clean global caches. Okay. RM, RF, cache, radar, rock. So, Rust C, env. How do I know what the global cache is? Cargo caches. There's no caches thing. Cargo cache? No. Cargo. Help. Grab cache. Nope. Um. Um. Maybe this is a thing that happened recently. Oh no, fucking the panda bot. No man. Why are you doing this? Okay, cargo uninstall. Error, found virtual manifest instead of a package manifest. Oh, is it path helix term? Unexpected argument path found. Oh. There's no cargo. Are you saying that it's not a valid URI? I don't know. I'm saying that maybe it is. I'm saying that all the URIs that I've seen up until now, they are like file colon slash slash, and then if they're absolute paths, there's a third slash foobar. Or in any case, it's file colon and then slash slash, and then the path. That's how we always seen them. So if your point is that this style of path should be supported, first of all, well, fuck, because my LSPs assume that the URI has a colon slash slash thing at the beginning. Oh, it's directly .cargo. Wait, why? 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 Wait. Oh no. Oh well, yeah. I mean, yeah, because there's bean, but there's no cache in here, right? Cache mutate. Global cache. But global cache is not a. It's not a directory, so I don't know. Technically, ZLS is not to blame here. Yeah, I don't know. No, I get that. I don't know. I don't know the specifics of what the protocol expects. If the protocol expects URIs and this is a valid URI according to RFC, then fine. I'm just saying that in the wild, that's usually not the case. That said, that would explain why Helix is able to make it work. I'm guessing that Helix implements this URI parsing correctly, and somebody else, like Neurosite with Flow, and me with my LSPs that do not. Is it under registry? Oh, yeah. But I think this might be, but this is just caching the version of packages, right? I'm guessing. Registry sounds like it's caching the result of checking on crates.io, not on of building something. To be honest, if I had to guess, I would expect the cache to be in here. There's a .cargo in here. Never mind, that only has, well, no, there's only a config toml in there. So maybe it's inside Helix term. Not really. Oh shit. A file URI with 1/ is specifically not allowed by RFC 8089. Uh-oh. This is RFC 3986 versus RFC 8089. So who's gonna win? Is this a Rust stream? Yes, it's complete madness, this stream. So it's me versus Cargo and Rust, Techatrix and Neurosite versus RFC 8089 and RFC 39. Actually, no, it's Techatrix versus Neurosite, RFC 8089 versus RFC 3986, Helix versus Flow in a sense. And it's madness. It's a PvP stream right now. I'm still unable to build my freaking editor though. I don't know what to do. Uninstall doesn't work. Install doesn't work. Cargo clean does nothing because it deletes 50 megabytes worth of files, but then it doesn't rebuild shit when you tell it to rebuild stuff. And then I'm getting parking lot core. Okay, you know what? It's time. It's time to Google this error message. Uh-oh. RFC 3986. Shit. So these are URIs that I could be given. Oh, man. For example, some clients, such as VS Code, may encode colons in drive letters while others do not. URIs below are both valid, but clients and servers should be consistent with the form they use themselves to ensure other party doesn't interpret them as distinct URIs. Clients and servers should not assume that each other are encoding the same way. For example, a client encoding colons in drive letters cannot assume the server responses will have encoded colons. The same applies to casing of drive letters. One party should not assume that the other party will return paths with drive letters cased the same as itself. Nice. Did you try running it without locked first? This fucking suggestion, man. They never solved it. They never solved it. What's the actual issue of LSPs as someone who has never really known what it's like to program without them? Right now, the issue that we're having with LSPs is that, is this a, wait, are you replying to X2? Let's see. It's unfriendly in the past decade, but damn, it is shit itself. It is. The issue with LSPs is that they have a very shitty wire protocol, which had no business being this bad. And then some parts of the spec are like weird and weirdly inconsistent. So, for example, if you look at what this stuff says here, it's weird. Yeah. So never mind. So I guess Techatrix, I accuse you of doing something wrong, but maybe it wasn't you after all. In my defense, this was the first time I was seeing this style of URIs, and I assumed, again, wrongly because I did not read the spec, but I assumed that the slashes were necessary. Okay, so here's my solution. Check out how I'm gonna solve this. ls cd home/cargo cd bin ls remove hx brew install a helix. Now watch brew also shit itself. Should have done this already before. Is it the white protocol just JSON plus WebSocket? Almost. It's JSON RPC, also WebSocket. No. The transport itself, I guess, could be WebSocket maybe in some contexts, but specifically to what most people do is that you just run the LSP as a process on your system, and then the communication medium is standard input, standard output. So your editor spawns the LSP as a process and sends stuff to its standard input and reads from its standard output. Then what you write on there is not just JSON, but it's JSON RPC plus some headers, some HTTP style headers, which I don't know if they're part of the JSON RPC spec. I think not. So you have these messages that are like, there's a header, like HTTP style, so like content dash length, and then the number of bytes that the next message is long, and then you have the JSON RPC framing around it. Why is this thing length prefixed in an HTTP style header? I don't fucking know. Nobody knows. It's completely redundant and annoying. Actually, it's worse than redundant because it makes it hard for you to just stream a reply over the socket. You have to first buffer, like you need to first allocate memory and print the message in memory so that you can know how many bytes ends up being, and then you can send over the wire the header with the length in bytes and then the message. It's dumb. It's dumb because you don't need the length, since it's JSON. You know when the message ends. I don't know why Microsoft did that. Okay, we got Helix. Ta-da! Success. Oh yeah, it is different, huh? Some things are indeed different. Well, let's see if what I was thinking about works now. Holy shit, it works. It works. I can select arguments. Well, Brew saved the day. What a weird adventure. Okay, so since everybody is here at this point, let's do this. Let's take a look at IO threaded cancellation. So let me bring up the example, the specific example that I was looking at the other day. Async examples. Implementing a stream parser. But you know what? I'm fine with. I think. Do you think that it would really make a big difference having a stream parser? I think that part is, I don't know, fine. But I find really puzzling that you cannot stream a message on the way out. That part seems so fucking weird to me. Because that part is much easier to pull off, right? You just have a writer and you just write. I don't know. Yeah, no, exactly. My point is like, I would like the stream. I would like the streaming, like being able to stream my rights. But for that to be viable, then we would have, like, you would have to remove the length thing at the beginning. Okay, so okay, we are looking at the IO thread cancellation thing. So here's the state of things right now in my Zig. Let me see if I can run it. Zig run source/server cancel.zig. Okay, so here's what you're seeing. Main thread is sleeping for 2 seconds and then trying to cancel a thing called loop a lot, which you can guess from the name what it's doing. It's looping a lot. And we send a cancel, but then loop a lot keeps running. So what is the problem? The problem is this. So this is our main function. We instantiated io.threaded. We call loop a lot in another thread. We obtain a future and then ignore the deferred. That's not interesting. What is more interesting is that we print sleeping for 2 seconds. Well, we print this message. We do sleep for 2 seconds, and then we try to cancel this future. Again, ignore the fact that I'm like canceling twice. That's not important. And it's idempotent, so it's fine. You can do it. Now, what's happening in loop a lot? What's happening in loop a lot is that loop a lot is not doing IO by itself much. Again, STD print is IO technically, but it doesn't play along with the whole async thing. So ignore that. But what it's doing is it keeps spawning tasks and awaiting them. Now, if this guy was doing, if instead of doing this guy was sleeping itself, then the cancel would work. Main cancel, and then returns error.cancel right away, because this sleep fails, well, returns io.cancel, like it gets interrupted. It returns error.canceled, and loop a lot ends, and this guy then surfaces to the top level the error.canceled error. But the fact that we are not sleeping, we're not stuck in a sleep syscall, but we are instead stuck waiting on another task to complete, right now with the current implementation, makes the cancel not work, because the cancel reaches this coroutine, but then it doesn't get propagated to this guy here. And so we just keep awaiting on it. And since we never do IO, we never get to acknowledge that we've been canceled. And which is why, in this case, the thing runs to completion. Okay, so Andrew has a patch. Share with me a patch. Well, with me, it's in Zulip, so it's for anybody who is present in Zulip that should fix this. So let's take a look. Let's try it out and let's see what happens. Okay, io.threaded. So there's wait and the init. Wait, do I have the new version already? Oh shit, I think I have the new version already in here. But this is not, I was using Zig. The one that I have in here as source is Zig 1. So let's try Zig 1 then. So Zig cancel does nothing. Okay, let's try Zig 1. Oof. Oh, I know what happened. We need to rebuild Zig 1. Might as well git pull at this point. Yeah. Yep, there's a few things that have changed. Oh man, poor ad type. Okay, so we're getting new Zig. Hopefully, these builds first try, and yeah. I'm still puzzled about those Rust failures. Like, what happened there? There's a proc macro executable that was failing, and apparently it wasn't even a valid macro executable. So maybe the thing that was given to me wasn't even a path to an executable at all. I don't know what that was. Hmm. Those executables were presumably those packages build scripts. I see. Oh, nice. Thank you, Neurosite. Okay, so far so good. Is yield for concurrent part of the IO interface, or is it going to be, or is that going to be make your own library thing? I'm not 100% sure how to interpret your question, Ivan. Sorry. I'll try my best. Yield is part of the design of async IO because you need it as a concept. So for the whole thing to make sense and work, coroutines need to be able to yield. So if you look at the various implementations, each will have its own version of yielding. For almost, I think Well, no, you know what? I think even io.threaded, which does only multi-threading with blocking IO, even that one still uses yield. I think that's an OS thing, right? For having a thread yield in general. Like you don't, I don't know what's called. In any case, I think yield, but I'm not sure. In any case, so yeah, each one of those things will have its own version of yielding. As a user of the library, like if your point is, man, should I do something like io.yield here? Would that make this better or what? For now, what we're trying to do is not give you yield. You're not supposed to call yield in user code. Every time you try to do IO, your IO implementation will attempt to yield will yield when it makes sense. For example, you try to read from a socket and there's nothing to read from the socket, then the coroutine will yield. But you're not supposed to do that in user code for now. The reason why it works like this is because we're attempting something different than other async implementations. We're attempting something somewhat unique, as far as I know, which is that we're trying to make this code also work in single-threaded code. So the idea is that when you write this stuff, you shouldn't be thinking about yielding. You should only be worrying about basically access to like multi-threading. Like you have to worry about the same things that you would have to worry if you were to do multi-threading, and then everything else should come somewhat naturally. But you basically you can essentially yield by doing any of the other operations. It's just not something that you're supposed to be doing manually. And so, for example, here is the problem, because in this version of when running this with the build of Zig that I was using, none of these things had the ability to yield. Or rather, await has the ability to yield. Sorry, but await wasn't. How can I say? Await wasn't wired into the cancellation system, and so that's why this thing was not acknowledging the cancel ever. How did you find the Zig project? A few years ago, I was working at Redis Labs, and I needed a way to show people how to write Redis extensions in a way that was better than just using C. And I was shopping for languages. I saw Rust. I saw Zig. I remember finding Zig very interesting because a few things about its design really clicked for me, and so I decided to try writing a Redis extension in Zig, and a Redis module to be precise. That's the correct terminology. And I had a good time. I had a significantly better time than doing the same in C. And I was kind of sold. And I remember that at the time writing Redis extensions or Redis modules in Rust was turbo cringe. So I remember saying, yeah, you know what, I'm going to stick with Zig. That's kind of it. And what the reason why I'm saying that it was like cringe in Rust is because when you were writing a module for Redis, you had to use the allocator provided by Redis, but you couldn't. How can I say? You had to use the God damn it, man! I'm retracing the experiences from that time in my head, and I hate some of my ex-colleagues so fucking much because they were so fucking dumb about all this stuff. But here's the problem. You need to use the allocator, the memory allocator that Redis gives you. Or rather, you should. You don't have to. You can use malloc. But what is the problem? The problem is that, the problem is that if you they had an SDK where they were swapping the global allocator with whatever Redis was providing them, but that would only work after you called some init function. Like, well, after Redis would call some init function. So Redis would call an init function that you defined, and it would give you access to the allocator, like pointers to where the allocator is exists in memory. And so their SDK would then take those values and set the global variables defined in the module that would give the allocator, that would set up the allocator. The problem is that if you had anything that would run, that would attempt to allocate before that happened, then that thing would do UB, because because you were basically trying to use the allocator that they configured before it got initialized. And I remember that they had like a dumbest possible crash because they were using a vector. So they had somewhere a vec exclamation mark, square bracket, like a Rust vector thing. And that thing uses heap allocation, and silently, it doesn't tell you, but it does. And yeah, and I had this crash in there. I don't know. In any case, the experience was not as good, in my opinion, despite the toolchain being more mature. So yeah, I stuck with Zig. Okay, we're getting to the end of this build procedure. Once it's done linking, we'll be good. Okay, our goal is now to run. So we ran previously this program with normal Zig. Now, Zig 1 should have, the one based on source on my computer, should have the new patch from Andrew that will have the cancel go through propagate to this guy, which will make this return iota canceled, which makes everything return iota canceled. Yeah, you know what? In the meantime, even though I'm building Zig 1, you know what? I just realized nothing can stop me from building Flow. I was thinking that I couldn't do both things at the same time, but actually I'm wrong because I'm using not Zig 1, I'm using normal Zig. Actually, Zig up 0.15.2. Okay, so we have new flow. Let's try it. Uh-oh. Still saying valid target URI. That's a way old version. Oh shit, which flow? Wait. User local bean flow. That should not be it though, because should I not be on branch master? Yeah. Mm, oh shit. Could it be that it's lying about the version for some reason? I think it's lying about the version for some reason. I don't know why. How do you do this? Gen version. Git describe. Oh, is this based on tags? Because it might just be that I haven't pulled tags. You want a suggestion on your site? I've started doing this, which works great for me. I import the zone file. I have an option to override the Ziggy version. Otherwise, I use the version inside the zone file. And then for releases, I have a thing that fetches the Zig version, the Git version, kind of like you do using tags. But then I complain if they don't match. So basically, I use zone as the authoritative version. I expect Git to have a matching tag if I'm making a release. And well, that's kind of it. So I don't know what to do, what I should be doing here. Okay, here we're almost done. Okay. Oh, Darius says the right thing. What the fuck? And it is different. What? I swear. What? What the heck? How? What? What? I have no clue what the heck is going on. I have no clue about what happened. Yeah, go-to-edition works. I still see invalid target URI floating around, but go-to-definition works. That's nice. Well, what can I say? There's no select rejects. Okay. Okay. Cool. Okay. To have Zig 1, so Zig run source server cancelled. So this is the old version. Okay. Loop a lot doesn't follow it. Let's try Zig 1 now. Okay, this one does follow. I feel like this error trace is missing something. Because I think this error trace, it would be nice if this error trace also pointed out that this is not just the top level feature that got canceled, but also the other one. Wait, this is 36. Yeah, 36 is this one. Yeah, it doesn't show that this one also return an error. But I guess it's understandable, maybe. Anyway, so this is nice. So this works. So here's the next problem. The next problem is this. By the way, Neurosite, you were saying that this is what the behavior that you expected, right? You expected the cancellation to flow through the await into the thing that is being awaited. So, well, we have that now. The thing that is missing is protection from this. Is protection from cancellation. It's protection from cancellation. Yeah. And I think it has to work like some kind of reentrant lock. That would be crossing stack threads, which could also be confusing. Well, error traces right now they're not stack traces, so some sort of unattached. Here's where things become interesting. That would not be that in my opinion would not be a good design. So here's the problem. If this were any other language, this suggestion would be fine, right? You would do something like well, you call it detached, but like you could call it, I don't know, concurrent detached, or you could call it concurrent uncancelable, for example, or you could do await uncancelable, for example. That also could. But here's the problem. The way it works right now is that cancellation is something that flips a switch in the thread running the current task. And so it makes all network operations to fail. It wakes you up from sleep and makes it impossible to go to sleep again. It basically turns any blocking thing into an immediate failure. Plus, it unblocks you if you're blocked. The problem is this. If we leave it as this, and the only way for you to protect yourself from cancellation is to spawn a separate coroutine and have that one be protected, the problem is that you're basically asking people to use IODO concurrent, not because they need concurrency, but because that is the only way they can get protection from cancellation. More specifically, the idea was, let's say that this is a web handler, and this is like a database operation where you don't want, it's a multiplex connection. So we're multiplexing a connection to a database. So it's being used by multiple coroutines at the same time. And we don't want to cancel it because if we do cancel it, we leave the connection in a dirty state. And so we basically fail every single thing that is trying to use that connection. So we basically, by canceling one web request, we obliterate all the others, and we don't want that. So the idea is you should be able to cancel one web handler, but this should be considered a critical section because we want the database operation to complete cleanly if it can. Or rather, we don't want to force it from the outside. Basically, like if the thing errors out on its own, that's a different thing. But from the outside, we don't want to force it to fail because then like the blast radius is too big. So my point is that if we do that, then we would force people to put all this stuff wrap this into an IO concurrent, even though it's not necessary, because it's not necessary for us to here do IO concurrent for the database operation. Maybe there could be a situation where we do have a reason to do that. But now, if we want to protect this connection, we would be forced to use IO concurrent, and it's a problem because, because it's a problem. What happens to a concurrent thread's defer when it is cancelled? Is cancel not allowed to kill the thread once begun? So like cancellation is guaranteed to occur, which makes sense. Yes, cancellation is not guaranteed to occur. Is cancel not allowed to kill the thread once begun? Cancel doesn't kill threads ever. Killing threads is a problem. Yeah, because if we were to kill the thread, then yes, the first would not run. No. What cancel does is this cancel here is canceling this future. This future is connected to the coroutine running loop a lot. So this coroutine running loop a lot how can I say? Just like this cancel doesn't kill the thread running loop a lot, but it just sets a flag. It sets a flag that, for example, io.sleep is able to see. What happens specifically with the io.threaded is this. It sets a flag, and then it sends a signal to the thread. So if the thread is stuck on a sleep syscall, receiving the signal unblocks it from the syscall. And then in io.sleep, there's a loop where it says, well, we got woken up, but did we sleep long enough? If we didn't sleep long enough, go back to sleep again. I you know what? I'm not 100% sure, but I assume it's implemented this way. I guess we can go take a look now. Most importantly, this gives a chance to io.sleep to observe that the flag has been flipped. Previously, this is all it did, and for await, it did nothing. Now, if this thread is stuck on a future.await, then we look inside, we know there's going to be a variable that has information about what it is that we are awaiting, and then we look into the other coroutine that we are awaiting, and we flip the flag in there. And if that flag is, and if that coroutine is stuck on a await, we do it again. We follow the chain all the way to the very end, and we keep flipping those flags over and over and over. So yes, it's IO calls that check the cancel bit, correct. So no, we never kill threads, because then the first wouldn't run, it would be a problem. So then when the flag is flipped, then every time you try to do you do io.sleep, you see that you have to try io.sleep, because io.sleep can return with, unsupported clock, but most importantly, it's cancelable, so it returns canceled. And so what happens is that io.sleep, it doesn't sleep. It will immediately return error.canceled. And so that way, all the defers run, and you decide what to do in that case. So this patch makes concurrent work that way, but now we need a way of protecting a coroutine from that. Maybe we can take a look at the code. So this stuff is in io.threaded. Function sleep Linux, for example, let's see sleep Linux. Yeah, look, there's a while true, check if we are canceled, and check cancel returns error.canceled if cancel was requested. And then otherwise it calls the sleep thing in Linux. And if it was interrupted, so whenever a thread receives a signal, the syscall gets interrupted. And so in that case, we continue and we loop again, check if we were canceled. Otherwise, go back to sleep again until we reach the expected time. So yeah. And you can see that canceling is literally just saying, let's see, we look at the current closure. Closure equals current closure, or else. I'm guessing this is a thread local variable. Yeah, there we go. So there's a thread local variable. So for this thread, this is what we are executing right now. This closure is basically it's the opaque part, it's the type erase part of the future. We load the we take a look at the flag where oh my god, canceling with one L. Wait, is canceling with one or two L's? Wait, is it really one L? Cancelled or canceled? Oh no. Guys. The version with one L is more common in American English. The version with two L's is more common in British English. Guys, I have to say one thing. In a sense, both have two L's. The American version with a single L is give skateboarding. Hello, everybody. The version with a single L. So, guys, canceled with a single L is a crime against humanity. I'm appalled. Skateboarding. Okay, everybody, check this out. So I don't have information. I don't have anything to share about me skating. But Giacomo, oh yeah, let's go, everybody. Here's what I have though. Check this out. This is Mason from the Zig. Well, he's in the board of directors. He's skating a bowl here in my town, and as you can see by the degree of imbalance of his stance, you can tell that he's doing something cool. Let me see what other photos I have. There's another one of him. And this one is Andrew. One day I will be also with them. Either I will be with them in the bowl or at the hospital. I don't know, something like that. So yeah. yeah. I'm looking forward. So here's my story with the skateboard right now. First time I hopped on my skateboard, I was able to do about 10 minutes of just pushing around, and then I fell from it and I rolled my ankle. And then I had to take like a couple weeks of a break, a 2-week long break, and then I was able to go back at it. First day I got a skateboard, I broke an arm. Good job, Outcross. Nice. Are sports allowed when you're in the Zig core team? Yeah, absolutely. Thank you, Giacomo. Have a nice day as well. Also, Toggle, if you're kick flips, okay. If you're going, thank you for the raid. Have a nice day. If you're staying for the skateboard stuff, then I don't know. Well, I don't know. I think I would guess that Mason knows how to kickflip. I don't know if Andrew practiced kickflips at all. I would have to ask him. In any case, we were complaining about the fact that in American English, it's cancelled with one L, and it's well, apparently it's more common, and it's I don't know. I find it disgusting. Cancelled with a single L. Like, look at this. Canceling. What is this? Canceling. It's like I don't know, a Zergling but cancer. I don't know. You can't unsee it now, huh? Yeah. Horrible, truly horrible. Yeah, underling or Zegling. Yeah. Canceling. It's horrible. So I don't know. I'm 2L team. I feel like in a sense there's like even if it's only one L, it's 2 L's still. Like well, okay, I don't know how to make this joke. Anyway, so we were looking at the implementation of cancellation in Zig. We need something to protect against this. I think that what we need. Okay, so I'll. kind people who do Rust, maybe this is something that you might find interesting. So I have a repo with some examples of stuff that we want to make sure works nicely with async IO in Zig. And to do one thing that I was showing here, very basic stuff, by the way, no weird acrobatics. We're still making sure that the basics work as they should. But here's what we're doing. So here I have a main function that creates an instantiates one implementation of IO, async IO. This one is called IO.threaded, and it's in a sense that it's the most basic version of IO. So it's an implementation of IO that uses blocking syscalls and does multi-threading. So every time you want to do something at the same time, so concurrently, it just spawns another thread. It doesn't do green threads. It doesn't do stackless coroutines. It's very, very simple. And also it's less performant, obviously, but at the same time, it's easy to reason about. And it's kind of like, you can think of it as like the baseline implementation. So here, what we do is we want to call concurrently a function called loopalot. And here we do it by doing try io.concurrent. So if you're not familiar with what we have in Zig we have io.async and io.concurrent. There is a difference between these two guys, like a critical one. And the difference is this. In Zig, we're making a distinction between asynchrony and concurrency. We like to say asynchrony is not concurrency. So here's the idea. Will Zig have algebraic effects like Coca? No, it won't. We just have an IO interface. And I know that there's a bunch of people that do functional programming that see something that vaguely resembles one of the things that they like to do, and then they like to say, oh man, look at these cavemen. They started to grasp the greatness of what we've been doing all along. That's not how it is. That's not how it is. Or you know what? Keep thinking whatever you want to think. Just don't complain when you get left behind. So IO is just an interface, and we have multiple implementations that fulfill the same interface. IO.async and IO.concurrent work this way. Normally, in most programming languages, when you use the async operator, or rather when you're calling an async function, you're implicitly asking for concurrency, which is weird. Why are you using an operator that's called async to obtain a thing called concurrency? That said, languages just conflate these two concepts, and then they just don't care. So here's the idea in Zig. The idea is the following. So let's say that you have a program where you want to do save file A and save file B. You just want to save two files. The order in which you save them doesn't matter. The fact that you're halfway through saving file A, and that's when you start saving file B, if that were to be the case, it wouldn't matter. You just have, at the end of the day, the only thing that matters is that you reach the end of the program, and here, both files have been saved. That's the only thing you care about. So in that case, what we like to say in Zig is that these two operations are asynchronous, one with respect to the other. So you can do first file A, then you can do B, or you can do first B and then you do A, or they can overlap. It doesn't matter. It just matters that at some point they're both done. So here, this what we call asynchrony. Concurrency for us instead is something different. Concurrency is something where you must have both things happen at the same time. And when I say happen at the same time, I don't mean that the impossible thing where at the same instance in time both things must be happening. What I'm saying is that their execution will span a length of time, and those two spans of execution must overlap because there's a handoff, there's a synchronization point in those two executions where both need to exist at the same time for the synchronization to succeed. One example could be that you have, for example, usually I do the server client example, but apparently people find that confusing, so I'm gonna try something different. Let's say that you have a function, there's like there's a lock. There's a lock that starts locked. And there is, let's say, there is func A that uses lock, then releases. Actually, no, wait, how do we do this? Let me think for a second. Yeah, it's a producer consumer also. It's another good example. The problem is that with producer consumer, if you have a buffer, the producer can just leave this stuff on a thread. They don't have to be alive at the same time. You know what? For my own convenience, I'll revert back to the client server example. So let's say that you have a test where you're testing some kind of like web implementation of something like a handler. So in your test, what you do is you spawn the server, and then you spawn the client. The server waits a client. The client wants to connect to a server, and then once the connection has been established, then some logic runs. So for example, you have your testing routine where like the client asks the server to create a new thing to save on the database, and then tries to fetch it, and it's successfully able to fetch it, right? So like it's a realistic example of what a test of client server interaction could look like. And so let's say then client asks server to do stuff. Once that succeeds, the test ends. So there's some logic in here where the connection has to happen, and then when the connection happens, the logic runs, and then after that, it's done. But what is the problem with this? While in a synchronous case, you could definitely you run save file A to completion, and then only after that you run save file B to completion. That is valid in this case. In this case, concurrency. In this case, you need to start the server, leave it running, start the client, and you can't wait for the server to finish running, because it's never going to finish running, because it's always going to wait for a client. It's going to be stuck there waiting for a client to connect forever. Similarly, you can't just start the client first, because if you start the client first, and let's assume that there is no race condition, like there's no race condition where the client could try to connect to a server that is not yet up. You can guarantee that. It's very trivial, so don't think about it. But if you try to run the client first without ever progressing the server, then the client will never successfully connect. So your test is never going to succeed. So for this stuff to work, you need to be able to run concurrently server and client. Both executions must overlap because they have in the middle a synchronization point where both need to be alive and do stuff in response to what the other thing is doing, and only then it works. So for save file A and save file B, you do io.async. So you do io.async, save file A, and then save file B, and this is fine. This works. While in this case, you need to do this. What is it? Spawn server, spawn client. So in this case, you have to do this. This one guarantees that execution of the main function continues, and that it doesn't block inside of here. And to guarantee that in the threaded implementation, the way this works is that every time you use io.concurrent, it will spawn a new thread. It will spawn a new thread to run this function, and it will spawn another thread to run this other function. In io.async instead, what you're saying is that that property is not, you don't have to uphold that property. It is also fine to serialize the execution of these two functions if the runtime decides to do so. In practice, the way this works is that the runtime will try to run stuff at the same time as much as it can, obviously, But then in this case, if it can't, so for example, let's say that we're doing a bajillion things all at the same time, and at some point we start running out of threads. The OS doesn't want to give us another thread. What happens here is that if this tries to spawn a new thread and the thread spawning fails, what io.async will do is that it will immediately just run the function. Like it will immediately just call the function in this same thread that we're in right now, where we call this function. Because it can, because the semantics of io.async is that things in sequence are still fine. But in this case, because of the nature of the relationship between these two guys, it can't. And you're not, like, if you do IO async spawn server and IO async spawn client, it's a programming error. Like you are using the wrong primitive because you're not upholding an invariant that is necessary, a property that is necessary for your computation to conclude successfully. So for this guy, we use io.concurrent, and as you can see, io.async cannot fail because the execution of this function will always be able to happen. Because, again, if we can find a new thread to run it on, great. If we can't, we're just going to run it immediately. But in this case down here, if we cannot spawn another thread, then it's another error that you will need to deal with yourself. So you will need to decide what to do if we are unable to spawn a new thread. So this is how it works in Zig. This is IO and, this is async and concurrent. So in this example, what we're doing here is that we are spawning a new thread that runs loop a lot, and loop a lot in a loop. It actually doesn't loop even all that much. It loops only 10 times, but loop a lot keeps spawning another thread in turn, and that thread just sleeps for 1 second. So what we were looking at is how cancellation should work, because here what we're doing is that we spawn this function. Let's ignore this defer. I'm gonna remove it. It's not important. So we spawn this thread. We obtain a future back. Then here we sleep for 2 seconds, and then we cancel this future. And so the question is, what should cancellation do? How should it work? So I was running it in an older version of Zig, like an unstable build of master branch. Does concurrency require parallelism? No, never. I often thought of concurrency just meaning that things can be interleaved. By the way, that is a good question, Calder. Thank you. So concurrency and parallelism does concurrency need parallelism? No, it doesn't. It absolutely does not. Concurrency enables parallelism. The fact that you have concurrency is, if you have a program where you only express the set of things that need to happen sequentially, without any opportunity for concurrency ever, or I should say asynchrony ever, then there's nothing that can be parallelized, because one thing, at least on paper, requires the previous thing to be completed to run successfully, or to obtain the correct result. But if you have things expressed in a concurrent fashion, so if you can express concurrent boundaries across different tasks that make up your program, then those concurrent things can be run in parallel. So does concurrency require parallelism? No. Here's an example. You can have a single CPU computer. The fact that it's a single CPU computer means that you have one CPU, so the thing can run one instruction at a time, but you can still have multi-threading on that single CPU computer. Single CPU, single CPU, single core. So even though you have a single core, if you have support for multi-threading, then you can have concurrency. And in fact, threads are not a unit of parallelism. Threads are a unit of concurrency. It's a way of obtaining concurrency. And in general, I think your point about the things can be interleaved is a good way of expressing it, because threads are the idea that you can take a sequence of instructions, what we generally call a task. So like, a series of things that kind of fit together, a function, roughly speaking. You put them in a single thread, and then what the hardware can do is take the thread, snapshot the CPU, leave the thread in memory on one side, load a new thread on the CPU, progress that other thread, pause it, and resume the previous thread, and continue from where it left off, because we restore the state of the CPU to what it was before. We put back the stack pointer, the program counter, and then we continue almost as if nothing happened. So that is concurrency. That is the ability to pause execution and resume it. Once you have that, then you can have parallelism. But parallelism, so concurrency enables parallelism, but parallelism can exist also regardless of concurrency. So for example, in other contexts, so here's another example of parallelism. SIMD instructions. SIMD instructions do multiple operations in parallel on a piece of data, but this is, and you do get parallelism, but you don't get, but this is not done through concurrency. This is done through a different mean. Or here's another type of parallelism that you can get from something that isn't concurrency. I think that this is where the asynchrony idea can trip people up. Asynchrony is about ordering, not mattering. Yes. But that sounds a lot like interleaving isn't important, but concurrency is saying that interleaving is required. Whereas asynchrony isn't a requirement. Yeah. Well, okay, maybe I should talk about this stuff like in the way they relate to one another, like one after the other. So if I were to give definitions for everything, I would say it like this. Parallelism is the property of being able to do more things at the same time. Oh, sorry, more things, or let me say it like this. To do an operation once, it takes you t time. If you're able to run that operation in parallel, then it means that you're going to be able to run this same operation 2 times, but it would still take you t time. It wouldn't take you 2 times t. So that is parallelism, is the ability to do multiple instances of the same thing, or like, for simplicity, let's say multiple instances of the same thing, but then the total time that it takes to do that is still the same time that it would take to do it only once. That's parallelism. So you have 8 cores in your CPU. Cores are a unit of parallelism because it's literally something that can do multiple things at the same time because you have many of them. So that means that if you run the same process 8 times, and you're doing some counting, I don't know, if every process gets scheduled on a different core, then you will be able to run that program to completion once in time t, or also run up to 8 instances of that same program, and it will still take you time t. Plus or less, plus or minus some overhead, because maybe there's, parallelism is also not something like, yes, no, that it's also a spectrum. Like you can get varying degrees of parallelism. There might be other things going on. So maybe you're not going to get exactly t. You're going to get t 1.01 times the original time execution. So it's not, perfect parallelism, but still you're going to get a lot of bang for your buck. So that's parallelism. Concurrency is threads, or green threads, or stackless coroutines. So it's a piece of computation that can be paused and resumed. And those can be done at different levels of abstraction. But I think that threads are like the quintessential example of this. Then that's concurrency. That's the ability of a system to pause execution of a task, progress another task, pause that other task, return to the previous task, and progress that one a bit, and keep juggling things that way. Asynchrony is what is necessary for things to be... Asynchrony is a thing that you can exploit to obtain concurrency, but asynchrony by itself doesn't require concurrency. It's another thing that requires concurrency. The thing that requires concurrency, in a sense, is when 2 things are not perfectly asynchronous. If you think about it, well, I deleted it, but the save file A, save file B example, that one could benefit from concurrency because because by running save file A on one thread and save file B on another thread, you could potentially, save 2 files in the same span of time that would take you to save 1 file. but you are able to save 2. So you get some parallelism out of that, and it's good. But it's not strictly necessary. The problem is when you have 2 coroutines that are not fully asynchronous, but instead they have asynchronous means that they don't require synchronization, right? But the client-server example is exactly the example where the 2 things are not fully asynchronous. They need to both progress at the same time, or rather, they both can do some progress. Sorry, they both can do some progress independently, but they have a synchronization point, at least one, the connection point, where they both need to have this handshake. And so when you do that, then the option of running them serially is not an option anymore because it's not going to work. And so that's why you need concurrency in that sense. So the point is that IO.concurrent, in the Zig implementation, IO.concurrent requests that capability. It's not just that it enables that. Like the way you should interpret it is that IO.concurrent is not something that says, well, you can do concurrency. No, IO.async already allows the implementation to do concurrency if it wants, but if it can. But it doesn't make concurrency a requirement for correctness. IO.concurrent does. It expresses that the thing requires concurrency. Otherwise, it's gonna deadlock. That's the difference. The difference. So yeah, so your point is not wrong. IO.concurrent is a stronger requirement. Yeah, absolutely. You should never prefer concurrent to async if async is okay. Like the only reason why you should go from async to concurrent is if async would lead to wrong behavior from your perspective, from what you want. I'll give you an example. Or rather, let's look at some examples. So we have save file A, save file B, for which I think we can all agree IO.async is the right choice, because if those can be done in parallel, then, concurrently, and then hopefully also in parallel, then great. If they can't, it's fine. We just save file A and then save file B, and who cares? It's a little bit slower, but if we're doing it that way, it's because we couldn't do it. We couldn't do any better, so it is what it is, but it's still correct. Server and client, we can agree it's an example where you need IO.concurrent, otherwise it's gonna deadlock. Otherwise, you're not gonna be able to offer the functionality that you need to offer. Here's another example. Let's say that you're running a web server. So for example, let's say that you're implementing the Ziggin web server. Should you use IO.async or should you use IO.concurrent? And I think that is a very interesting question. So you're running a development server, right? So nothing crazy, but it's a development server for your static site generator, and you use it to serve local assets to a local client, so that they can preview their website. Should you use, when you receive a new web request, should you handle that request using IO.async or should you use IO.concurrent? And you know what's interesting? I think the reason why I'm bringing this example up is because it's not immediately obvious what the right answer is. I'm actually personally not even sure what the right answer is 100%. I know some people in the core team have opinions about this, but I'm not 100% sold on their arguments. Well, while you guys think about the answer, in case that you are, let me finish demoing this thing. So for the people who are coming from Rust, who want to watch, who haven't seen this yet, So here's what an older implementation of Zig was doing. So we are sleeping for two. Well, from main we launched the loop a lot thread that then spawns other threads in turn. We try to cancel it, but canceling does nothing because it doesn't listen to it. And the reason for that is because the old implementation wasn't propagating cancellation to other things that you might have been awaiting on. So the problem is that this IOTA concurrent call would run, but or rather, what would happen is that we cancel this future here, and this future is connected to a thread running this thing. So we flip a flag that says that this thing, the cancellation has been requested for this thing, but this thing is not observing it because it's busy awaiting on another thing to complete. And await by itself, it just blocks there and it doesn't do anything. Like it doesn't actively unblock on cancel. If we were to sleep directly or do any IO, then it would be cancellation would be immediately received because IO.sleep would immediately unblock and return with the cancellation error. But await wasn't doing that before. There's a new change in master branch where now instead, even if we are awaiting on something, we do have the cancellation. Oh wait, the error trace now has something more. Return f.result. Interesting. Oh. Sorry, let me see what's this line. Okay. Oh, doesn't help much. Okay, so the new version of Zig instead works this way. Cancellation, when it sees that a thread is stuck awaiting another thread, it looks into the other thread and cancels that one as well. And if this guy here was for any reason awaiting something else, then it would chase also that thing. I think we can take a look at this in the implementation. Request cancel, wait and the init. Was it this one? AC reset event dot wait catch switcher cancel, request cancel, reset event, wait and cancelable. The init, was it this one that we were looking at? Async closure. Dot wait t. That surprises me. Let me take a look at the patch from Andrew. Yeah. Okay, so we try to wait and we obtain error.cancelled, which we should be getting. Okay, so we do AC closure request cancel. What is closure here? This guy. So first we do request cancel, then we do wait and the init. And if wait returns error.cancelled, then we do AC request cancel again. And then we do wait and cancelable on reset event. Interesting. So I'm not sure. I think I'm missing something else. Threaded. What is threaded? Oh, right. It's ourselves. I'm curious exactly how this cancels other threads though. Not immediately obvious. It has to be this line. I guess it's just I don't know what's the closure precisely. Oh, I know what it is. Wait, it's a linked list of nodes. Set to canceling. What I don't understand is I'm missing the part where this becomes a thing that affects the other thread, though. But that's me not understanding the code. Well, in any case, I think that at this point, what we need is something to protect from cancellation, something like this. Something like this. Or defer. Something like this. Okay. So, you know what? Since we don't have a lot of time to do anything, I think I'm gonna stop the stream here, and I'm gonna get ready for the meeting that we have in about 20 minutes or something. So yeah, let me see if there's anybody to continue raiding. Do anybody doing Zig by any chance? Nobody doing Zig. Oh no. C sharp? No. C plus plus? Hmm. Oh, Tim Bode is working on a racing game, right? I haven't rated him in a while now. Let's rate him. So see you all next time.